our next section, we will talk about Cisco wireless infrastructure. Let's start with the access point types and connecting to Cisco access point. A Cisco wireless network can consist of autonomous access points or lightweight access points that are coupled with one or more wireless LAN controllers. As you can see in the screen, we have an autonomous AP in here and we have the lightweight AP in here. The autonomous AP is connected to a switch network via a trunk link, and this lightweight AP is connected to a switch LAN mostly with an access link. But lightweight AP is communicating with the wireless controller also, as you can see in here, with CapWeb. Okay, after this brief information, let's talk about in some more detail about these two types. An autonomous access point is a standalone device and nothing else is needed to forward the Ethernet frames from a wired WLAN to a wireless LAN and vice versa. In effect, the AP maps each WLAN to a wireless LAN and BSS. The autonomous AP has a single wired Ethernet interface as shown in the left portion of figure and as I showed you, which means that multiple WLANs must be brought to it over a trunk link. A lightweight AP also has a single wired Ethernet interface, however, it must be paired with a wireless controller to be fully functional. Wired WLANs that terminate at the wireless controller can be mapped to wireless local area network that emerge at the access point. Even though multiple WLANs are being extended from the wireless controller to the access point, they are all carried over the CapWeb tunnel between the two. That means the access point needs only an access link to connect to the network infrastructure and terminate its end of the tunnel as shown in the right portion of the figure. So, if you want to configure and manage Cisco access points, you can connect to a serial console cable from your PC to the console port of the access point. Once the access point is operational and has an IP address, you can also use Telnet or SSH to connect to its CLI over the wired network. Autonomous APs support browser-based management sessions via HTTP and HTTPS. You can manage the lightweight APs from a browser session to the wireless controller. Okay, but how are we gonna access to the Cisco wireless controller? To connect and configure a Cisco wireless controller, you will need to open a web browser to the wireless controller's management address with either HTTP or HTTPS. This can be done only after the wireless controller has an initial configuration and management IP address assigned to its management interface. The web-based GUI provides an effective way to monitor, configure and troubleshoot a wireless network. You can also connect to a Cisco wireless controller with an SSH session where you can use its CLI to monitor, configure and debug activity. Both the web-based GUI and the CLI require management users to log in. Users can be authenticated against an internal list of local usernames or against an authentication, authorization, and accounting AAA servers such as Takax Plus or Radius. When you first open a web browser to the management address, you will see the initial login screen. Once you click the login button you can see in here, once you click this button, Then you enter your credentials as you are prompted for them. When you successfully logged in, the wireless controller will display a monitoring dashboard similar to the one you can see in the figure, guys. You will not be able to make any configuration changes here. You must click on the advanced link, you can see it here, to make some configuration changes. And in here you can see some network summary and total wireless network counts, how many access points you have, how many active clients you have, and some rogue IP information, and interferer is here also. Once you click the advanced button, this will bring up the full wireless controller GUI as shown in the figure. You can select categories of functions from among. In here you can also see that monitor, wireless LAN, controller, wireless, security, management, commands, help, and feedback. So the vertical list of functions at the left side of the screen will change accordingly once you select one of these options. You can expand the list entries if needed and select one to work on. The main screen area will display all of relevant fields and options you can edit as you make a configuration change. So, how we can connect to a Cisco wireless controller? Let's talk in detail about this one. So guys, connecting a Cisco wireless LAN controller to the network is not quite as straightforward because it has several different types of connections. Controller ports are physical connections made to an external wired or switched network, whereas interfaces are logical connections made internally within the controller. You can connect several different types of controller ports to your network, as you can see in the screen. So you can see here we have service port. This port is used for out-of-band management, system recovery, and initial boot functions. Always connects to a switch port in access mode. And we have also distribution ports in here. And these ports are used for all normal access point and management traffic, and usually connects to a switch port in trunk. So here is mostly trunk, and here is the access ports. And we have also console port in here, you can see that, and this port is used for out-of-band management, system recovery, and initial boot functions. And we also have the redundancy port, and that is used to connect to a peer controller for high availability. So let's go ahead with connecting the Cisco wireless controller. Through its distribution system ports, a controller can connect to multiple VLANs on the switched network. Internally, the controller must somehow map those wired VLANs to equivalent logical wireless networks. For example, guys, let's suppose that VLAN 10 is set aside for wireless users in the engineering division of the company. That VLAN must be connected to a unique wireless local area network that exists on a controller and its associated access point. The wireless local area network must then be extended to every client that associates with the service set identifier and SSID engineering. So, Cisco wireless controllers provide the necessary connectivity through internal logical interfaces which must be configured with an IP address, subnet mask, default gateway, and a DHCP server. Each interface is then assigned to a physical port and WLAN ID. You can think of an interface as a layer 3 termination of a WLAN, guys. So, Cisco controllers support following interface types that you can see in screen also, and the first one is the dynamic interface. Dynamic interface is used to connect to a WLAN to a wireless local area network. You can see in here. We also have the management interface. You can see also in here. And management interface is used for normal management traffic such as reduced user authentication, web-based and SSH sessions, SNMP, NTP, and so on. The management interface is also used to terminate cap web tunnels between the controller and its access point. And also we have the redundancy management interface. And this is the management IP address of a redundant wireless controller that is part of a high availability pair of controllers. The active wireless controller uses the management interface address, while the standby wireless controller uses the redundancy management address. And we have also in here the service port interface. And this interface is bound to the service port and used for out-of-band management also. We also have the virtual interface and IP address facing wireless clients when controller is relaying client DHCP requests, performing client web authentication, and supporting client mobility. And we also have the virtual interface, which is the IP address facing wireless clients when the controller is relaying client DHCP requests, performing client web authentication, and supporting client mobility. So let's talk about the configuring a wireless local area network. A wireless local area network controller and an access point work in concert to provide network connectivity to wireless clients. From a wireless perspective, the AP advertises a service set identifier which is known as SSID for the client to join. From a wired perspective, the controller connects to a virtual LAN VLAN through one of its dynamic interfaces. And to complete the path between the SSID and the VLAN, as illustrated in the screen, you must first define a wireless local area network on the controller. So let's go step by step how we can configure a wireless local area network. If your new wireless local area network will use a security scheme that requires a radio server such as WPA2 Enterprise or WPA3 Enterprise, you will need to define the server first, guys. And you need to select, you can see in here, security, AAA, and the authentication, and you need to click new. Once you click the new, you will go to the screen that you can create a new server. And next, you need to enter server's IP address firstly, okay, and shared secret key, and the port number. If you already had two other radio servers configured, the server at 200.30 will be index number 3, as you can see in here. Be sure to set the server status to enabled so that the controller can begin using it. At the bottom of the page also, guys, you can see the type of user that will be authenticated with the server. You can check the network user to authenticate wireless clients, or management to authenticate wireless administrators that will access the controller's management functions. Then you need to click Apply button in here to save your configuration. The next step is creating a dynamic interface. A dynamic interface is used to connect the controller to a WLAN on the wired network, as I explained to you before. When you create a wireless LAN, you will bind the dynamic interface to a wireless network. To create a new dynamic interface, you navigate the controller and the interfaces, and you just click the new button to define a new interface. Then you enter a name. As you can see in here, the name is engineering, and you just define the WLAN ID, which is defined 100 for this example. Next, you need to enter the IP address, subnet mask, and gateway address for the interface. Okay, you can see in here, and they are all defined. And also you should define primary and secondary DHCP server addresses that the controller will use when it relays DHCP requests from clients that are bound to that interface. And here is the DHCP information defined, as you can see in here. Okay, as a summary, it is defined an IP address with 110 and with a net mask with 255.255.255.0, and gateway is 100.1. And we have two DHCP servers, and they are 1.17 and 1.18. Once we accomplish here, we just can click Apply to save our configuration. Okay, after creating the dynamic interface, then step 3 is creating a new wireless local area network. You can display a list of the currently defined wireless local area networks by selecting Wireless Local Area Networks from the top menu bar. In figure above, the controller does not have any wireless local area networks defined already. You can create a new wireless local area network by selecting Create New from the drop-down menu and then clicking the Go button. Okay. Next, enter a descriptive name as the profile name and the SSID text string. You can see all these definitions on the figure below, and the profile name and SSID are identical, and they are both set to engineering, as you can see in here, and this is just to keep things straightforward. The ID number is used as an index into the list of wireless local area networks that are defined on the controller. The next page will allow you to edit 4 categories of parameters corresponding to the tabs across the top as shown in the figure. You can control whether the wireless local area network is enabled or disabled with the status checkbox. In here you can see the checkbox regarding the status. And even though the general page shows a specific security policy for the wireless local area network, you can make changes in a later step through the security tab. And under radio policy, you can see that one here. Select the type of the radio that will offer the wireless local area network, and by default the wireless local area network will be offered on all radios that are joined with the controller. And next you need to select which of the controller's dynamic interfaces will be bound to the wireless local area network. You can see in here we are binding the engineering, right? Okay, the drop-down list contains all the interfaces names that are available, and the new engineering wireless local area network will be bound to the engineering interface that we already created on our previous step. And finally, use the broadcast SSID. There's a box in here that you can check. So use the broadcast SSID checkbox to select whether the APs should broadcast the SSID name in beacons they transmit. Broadcasting SSIDs is usually more convenient for users because their devices can learn and display the SSID names automatically. In fact, most devices actually need the SSID in the big beacons to understand and that the AP is still available for that SSID. Hiding the SSID name by not broadcasting it, does not really provide any worthwhile security. Instead, it just prevents user devices from discovering an SSID and trying to use it as a default network. And also, let's go ahead with the security tab. That is the second tab. And this is the place that you can configure the security settings. As you select a security type, be sure to remember which choices are types that have been deprecated or proven to be weak and avoid them if possible. Further down the screen, you can select which specific WPA, WPA2 and WPA3 methods to support on the wireless local area network. You can select more than one if you need to support different types of wireless clients that require several security methods. And also in the screen, WPA plus WPA2 has been selected from the pull-down menu. Then only WPA2 and AES encryption have been selected. WPA and TKIP have been avoided because they are legacy and deprecated methods. Under the authentication key management section, you can select the authentication methods the WLAN wireless local area network will use. Only pre-shared key has been selected in the figure, so the wireless local area network will only WPA2 personal with the pre-shared key authentication. And when you switch to the AAA servers tab, you will have an option to define different radius servers for authentication will be used for WLAN authentication, and here you can see that 3 different radius servers are defined already. And by default, a controller will contact a radius server from its management interface, and you can override this behavior by checking the box next to radius server override interface so that the controller sources radius requests from the dynamic interface that is associated with the WLAN. And here is that option. You can see the option in here. Okay, once you change to the QoS, we can define some QoS parameters for our wireless local area networks. So you can simply select the QoS tab to configure quality of service settings for the wireless local area network as shown in the figure. By default, the controller will consider all frames in the wireless local area network to be normal data to be handled in a best effort manner. You can set the QoS drop-down menu to classify all frames in one of the following ways, and they are Platinum Voice, Gold Video, Silver Best Effort, and the Bronze Background. Finally, you can select the Advanced tab to configure a variety of advanced wireless local area network settings. As you can see in the figure, you can enable functions such as coverage hole detection, peer-to-peer blocking, client exclusion, client load limits, and so on. Although most of the advanced settings are beyond the scope of the CCNA objectives, you should be aware of a few defaults that might affect your wireless clients. So the first thing is here. By default, client sessions with the wireless local area network are limited to 1800 seconds, which equals to 30 minutes. Once the session time expires, a client will be required to re-authenticate. This setting is controlled by the Enable Session Timeout checkbox and the Timeout field. The controller maintains a set of security policies that are used to detect potentially malicious wireless clients as well. If a client exhibits a certain behavior, the controller can exclude it from the wireless local area network for a period of time. By default, again, all clients are subject to the policies configured under Security Wireless Protection Policies and Client Exclusion Policies. These policies include the excessive 802.11 association failures, 802.11 authentication failures, and 802.1x authentication failures, web authentication failures, and and IP addresses theft or reuse. Offending clients will be automatically excluded or blocked for 60 seconds as a deterrent attacks on the wireless network. And finally, when you are satisfied with the settings in each of the wireless local area network configuration tabs, you can click the Apply button in the upper right corner of the wireless local area network edit screen. The wireless local area network will be created and edit the controller configuration, and in here you can see we created a new wireless local area network, and WLAN ID is WLAN 1, type is wireless local area network, our profile name and the WLAN SSID is set to engineering, and admin status is already enabled, and here is the security policies.